Assalamualaikum students. Today's topic is going to be about head to tail rule. For that we have to understand like parallel forces. Like parallel forces are the forces that are parallel to each other and have the same direction. Just like over here, the apples have all the same direction. All the apples have the same direction, which is in downward direction. The figure shows a bag with apples in it. The weight of each apple of the weight of the bag is due to the weight of all the apples in it. Since the weight of every apple in the bag is the force of gravity acting on it vertically downwards. Therefore, the weight of apples are parallel forces because all of them have the same direction. All of these forces are acting in the same direction. Such forces are called parallel forces. Unlike parallel forces are the forces that are parallel but have the direction opposite to each other. Just like in this diagram, that there is an apple hanging from a thread, and thread had a tension in it, which is acting in the upward direction, whereas the weight of the apple is pushing it down. So these two forces have opposite direction, but they have the same magnitude. That is why the apple is not moving. In the figure, apple is suspended by a string. The string is stretched due to the weight of an apple. The forces acting on it are the weight of the apple acting vertically downwards and the tension in the string pulling vertically upwards. The two forces are parallel but opposite to each other. These forces are called unlike parallel forces as shown in the figure. Addition of forces. A result forces or the resultant of forces is a single force that has the same effect as the combined effect of all the forces to be added. Just like in this case, let's say the red vector or the red force R has the combined effect of this force, let's call this force A, and this force, let's call this force B. Now, one of the method of addition of forces is graphical method, which is as shown in the diagram. In this method, the forces can be added by head to tail rule of the vector. Now let us read about head to tail rule. What does this mean? Now, in this case, figure 4.5, let's say this is the figure we want to show. Let's say this is the figure of 4.5, that there are two vectors A and two vectors B which are acting along the north, east, west side of the plane. The graphical method of vector addition is first select a suitable scale, then draw the vectors of all the forces according to the scale. Now let us see that the scale is basically the vector A and vector B are presentable now. Then draw the vector of all the forces according to the scale, such as A and B, and these A and B vectors are to the scale. That means you can see them on a page. Take one of the vectors as the first vector, the example vector A, then draw the next vector, vector B. Now we have a vector A as well as vector B, such that it stays coincide with the head of the first vector A. Similarly, draw the next vector for the third force, if any, but we only have two vectors, so we will add them both, with the tail of the coinciding with the head of the previous vector. Now let us show how this performs. This is vector A and this is vector B. Now the paragraph said that you have to join the head of the first vector to the tail of the second vector, and so on until you find the resultant vector, which is R. Now draw a vector R such that its tail is at the tail of the vector A and the first vector, while its head is at the vector of B. The last vector as shown in figure, let's show this as like this. Let's draw the tail of the resultant vector R at the tail of the vector A and the head of vector R at the head of vector or B, or the last vector you will say. Vector R represents the resultant force completely in magnitude and direction. So this vector R basically is showing the resultant of these two vectors. Now, how can we resolve the forces? How can we break up the forces? Consider a force F represented by OA making an angle with the x-axis as shown in the figure. Let's say that how we can show the figure. We can basically take a vertical axis, we can take the horizontal axis, and let's draw a figure of a force F. And it is broken up into its two components. One is along the y-axis, the other one is along the x-axis. And the same concept is the definition of resolution of forces, which states that splitting up of forces into two mutually perpendicular components is called resolution of that force. Now we have considered already that there was a force and the distance between the forces had a basically line segment of OA, which is over here, right here, and has an angle which is over here. Let's call that angle theta with the x-axis. Draw a perpendicular AB on x-axis from A according to head to tail rule. Now we will draw head to tail rule. That means one vector is drawn from here, the one vector is drawn from here, which is vertical. Now by head to tail rule, the tail of the resultant vector is at the tail of the first vector, which is the horizontal vector, and the head of the resultant vector is at the head of the last vector, which is the vertical vector. And by that we know the OA is the resultant of vector represented by OB. That means OA, this vector, is the resultant of OB and BA. So we can write it down like this: AB is equal to OB plus BA. The components of OB and AB are perpendicular to each other. What does perpendicular mean? Perpendicular means that they have a right angle with each other. Now, it says there are called perpendicular components of OA. That means they are the perpendicular components, just like in a right angle triangle. Hence, OB represents its x component as fx. So we can say that OB is represented by a line which is called fx, and BA, its y component, is represented by fy. So AB or BA can be represented by fy. Therefore, the equation can be derived from here, that we have a force which is broken down into its components, and now we are going to resolve the two components of x and y by the help of a triangle which we have already drawn, but we are going to make it clear. So the right angle triangle which we saw before was the triangle OAB, and from that we are basically taking cos. So what was cos? Basically base over hypotenuse, but at the base we had fx, and at the hypotenuse we have f, that means the force. So from that, if we take f to the other side, it will be fx is equal to f cos theta. That means the horizontal force is found by the help of trigonometry. Let us call this equation A. Similarly, for the y component, we will take the vertical component and divide it by hypotenuse. So fy was the vertical component and f was the basically hypotenuse. Taking to the other side, we can rearrange it and we can write it down like fy is equal to f sine theta. That means fy is equal to f sine theta, where f is representing the hypotenuse. Let's call this equation B. Now we have the components vertical and horizontal in equation A and equation B. From equation A and equation B, fx and fy can be calculated, and the angle theta which f makes with the positive x-axis is in anti-clockwise direction. That means we have to measure anti-clockwisely. Now, how can we determine the force by these components? Very easy. Now, if fx and fy are the given values, find the resultant by simply by adding them according to head to tail rule. Like this, the head of the first vector where it ends, the tail of the second vector starts from there, and so on until the last resultant vector, which says the tail of the resultant vector is at the tail of the first vector and the head of the resultant vector is at the head of the last vector. And as we know, the diagram is not according to the scale, so the right angle triangle forms as shown in the figure to find the magnitude of the resultant f by Pythagoras theorem. Pythagoras theorem says hypotenuse square, which means this square, is equal to base square, that means fx square, plus perpendicular square, that means the perpendicular part square. Now, what was at hypotenuse f? What was at base fx? And what was at perpendicular, that means fy? Now, putting in the values in the Pythagoras theorem, we'll get fx square is equal to fx square plus fy square is equal to, we can take under root on both sides, we'll get f is equal to under root fx square plus fy square. Remember, the blue color is representing the horizontal part and the red color is representing the vertical part. Similarly, we can find the direction. The direction can similarly be found by a tan formula, which is also in trigonometry, which says tan is equal to perpendicular over base. What was perpendicular? Fy, and the base fx. In this way, we can put in the values and find out the value of theta. That means taking tan inverse to the of the equation, we get theta is equal to tan inverse fy over fx, and this way we will be able to calculate the direction of the vector f. I hope you understand this lecture. Inshallah, we'll meet again. Allah Hafiz.